Hi, this is Jeff Heaton. Continuing on with some of the presentations that I gave at a conference recently, I'm going to talk about predictive analytics, the Tower of Babel. So why do we have so many programming languages for predictive analytics? And I'm going to look at several of them. You see them here. And talk about the differences in syntax between the two and look at a very similar program, the Titanic dataset, trying to predict if somebody lives or dies on each. For the latest on my AI course and projects, click subscribe and the bell next to it to be notified of every new video. This is an abbreviated version of a conference proceeding that I did at the Predictive Analytics and Research Symposium for the Society of Actuaries. This is the all-important slide that says that the views expressed here are my own, and I do not represent the Society of Actuaries, nor do I represent my employer, RGA. These are the programming languages that I'm going to take a look at. This is basically talking about an electronic Tower of Babel. So what is a programming language? A programming language is not like a natural language. Programming languages grew out of mathematics, where you had things that would no longer fit into nice equations and summations. You needed to iterate through loops, things like Newton's method and other things like that. Natural languages are languages like English, French, and Spanish, Chinese, Japanese, others that let you encode human knowledge and converse with others. They're not the same thing. I mean, try to translate Shakespeare into Python. There are different types of programming languages. There's domain-specific programming languages. These are languages that were meant for something very specific. And then there's general-purpose programming languages like Julia, Python, and Scala that I will take you through here. Now, you could write a video game in R, or you could write a video game in Microsoft Excel, but why? It's just really not what they were designed for. The Sapir-Whorf hypothesis, you'll hear about this sometimes in natural human languages. This is talking about how much does the language shape our thoughts. There was a very good movie about this that Stephen Wolfram and his son did the languages for, where a new alien race came to Earth and we saw a new language from this alien species that we had never seen before. And they had a very different thought process from us because they had a very different language. This gets into programming languages. Are certain languages better for certain tasks? And of course, Turing completeness. For a programming language to be any particular use, it has to be Turing complete, meaning it can compute theoretically anything. Now, if you care about raw performance, this is usually not necessarily a good reason to pick a programming language. If you just want hardcore performance, learn C and you're somewhat done. And then compile that C to whatever hardware you are going to run it on so that all the performance optimizations are happening. However, human hours and CPU hours cost radically different amounts of money. It's usually cheaper to throw hardware at it than it is to pay a highly specialized professional to optimize your code. But this does show you that, for example, Python, pure Python, quite slow if you use it. You need to be using things like SciPy and NumPy in conjunction with Python. If you are using Python and you're getting ready to abandon it because it's too slow, you're probably doing it wrong. So I'm going to use a data set here that is the Titanic tutorial challenge. This is a good one. I'm a little sick of Iris, and this is also somewhat fits the category of the conference I'm presenting at. It is somewhat actuarial because at least people are dying. So it has mortality questions. So we're looking at, does somebody live or do they survive? And we have the passenger class, the name of the person, the gender, age, all of this. There's many talks that have covered Titanic data before. You do very interesting things like engineer titles out of the name, look at the ticket classes, see if you can tell where they're sitting, look at the fare, other things. Also, the city that they started from can be very important. Now, all code is available on GitHub. I also have a Google Colab shareable notepad that contains the Python and R versions of this. So let's start with Python. Python is a general-purpose programming language, is a typeless programming language, which means you're not saying things like integer I. The thing you have to be really careful with, though, is 1 plus 1 2 or is 1 plus 1 11? If your numbers are strings and you add things together, you're going to end up with 1 plus 1 equaling 11. And you have to be careful with that when the programming language is inferring the type. You've got TensorFlow, NumPy, SciPy, and a bunch of other highly optimized linear algebra packages you can use for Python. Python. It's a very large community of add-on libraries, extensive array of machine learning, statistical, and artificial intelligence libraries. It's a shallow learning curve. You can get up and running on Python pretty quick. Not a lot of formality in the language, so there's not as much overhead as some other languages like Java. It's a great glue language. One criticism and praise, I view it more of a praise that I've heard of Python, is it's often said to be the second best programming language for just about everything. Nested loops can be slow if you're not using something like NumPy, SciPy, or TensorFlow. If you're doing heavy nested loops over large numbers, you're doing it wrong. You need to be using NumPy. Libraries may not always have out-of-the-box support for Windows or Mac. Linux is sort of the king platform for Python. Windows and Mac, especially Windows, are often supported somewhat begrudgingly. There's still a lot of Python 2 programmers out there, although Python 2 is finally, thankfully, reaching its end of life and will be no longer supported and recognized to be an obsolete version of Python. Programmers will either love or hate the white space scoping, so a tab means something. Spaces mean things. That's how you nest things and specify what code is going to run under a loop. Here's the Python example. I give you a quick function that I wrote there to encode the dummy variables. Dummy variables are where you have categories, like those 3 cities that they started at. And I essentially loop through, I create the dummies, loop through, and append the dummies to there. So for those 3 ports that the Titanic visits on its way out, there will be 3 columns, each one being yes or no. Did the person start from that port? I use pandas to read in the CSV file that contains the Titanic data. Pandas is great. It makes Python very much like R's data frame. I drop the columns that I don't need. You'll see different ways that the programming languages handle this. Some make you drop the columns that you're not going to use. Some simply have you specify what you're using, and the others can simply stay there and be ignored. For male and female, I am not treating that as a dummy variable. It is a categorical, but I'm making female 0, male 1. Works just as well if you flip those two. I get the median of the age, and I fill in any missing ages with the median. This is a very primitive way to handle missing values, but the purpose of this talk is not how to handle missing values. And if there's any missing ports of call or ports that they're starting from, then I fill in Southampton because that's the most common one. Again, very primitive way to handle that, but that's how I do that. Then I encode the text dummies for impart. You'll notice this is differences between the programming languages as well. I specify what I am going to extract here. So I didn't necessarily have to drop those, but I just like to not have the extra data necessarily hanging around. And I convert the Y column into just a list of zeros and ones. Did they survive or did they not? I do a train test split using the Hitchhiker's Guide to the Galaxy number of 42. As a seed, so it's consistent. I'm going to use logistic regression, and I'm going to fit the x to the y. You'll notice we are specifying logistic regression, which means binomial family and a logistic link function. Other languages will just say GLM here, and we'll have to specify that. Then I predict, and I call metrics, and I get the accuracy score. So you usually get about 80% correct on this. The R programming language. If you're a data scientist, you need to be able to converse in R and Python. I do believe that Python is beginning to surpass R in this space. Just definitely my opinion. Let me know in the comments what you think. What's your favorite language to use for predictive modeling and data science? Reasons to use R: support for vast array of statistical techniques. I will see obscure, or at least obscure to me, I'm a computer scientist, statistical techniques in R that I've not seen in Python and sometimes have trouble reproducing in Python. Statisticians who develop new methods often do R first. KDD Nuggets rates R as, at least at the point that I put that bulletin, most commonly used language. Nevertheless, you need to know R and Python in data science. Some reasons not to use it, and I agree somewhat with this first one. R is unusual compared to other programming languages that I've dealt with. R generally must fit everything into RAM, and without commercial support for 64-bit can be challenging. Larger learning curve than Excel or Python, and not commercially supported like Excel, SAS, and MATLAB. Here's my R example. I'm going to load that same data set. I am putting in the columns that I want to drop. Don't really have to drop these. R is smart enough that I could say just don't use them later on, but that's fine. So we drop these. This is a difference we'll see in some languages. This is vector or matrix notation right here. That's space. You would put a colon there in many other languages. This just means all rows, but then these columns only only the columns that are not in the drops. The age I'm going to fill in for median. It's important on the median to specify that you do not want the NA values to contribute to the median because they will cause the median to be incalculable. In BART, we're going to default to Southampton. Sample size is rounded the number of rows in the data frame times 0.75. We set a random seed and we randomly sample that number of rows. And we set the training set to the index for training, and the test set is anything that is not in the training index. So that minus sign is essentially flipping the Boolean trues and falses that we have there. And what that is going to do is cause you to get essentially the opposite set of train. You can also use it to apply a negative to every number, but since these are Boolean, it just flips them around. We create the GLM, family is binomial, and the link is the logistic. So this is essentially creating the model, the GLM, and we specify what type of GLM we want, rather than just saying logistic regression, like we do in other languages. We fit and evaluate the model. I get the predictions. I want the response, and I am going to round these. So anything that is a 0.5 prediction or lower, or not including 0.5, 0.5 and above would be survived, 0.5 below would be perished. And then I print out the accuracy. SAS. Now, I will not claim that I'm a particularly advanced SAS programmer. I largely just translated my code into SAS using a university edition at WashU. SAS is good because it's compatible with, it's easy to move from SPSS. It can use disk in addition to RAM, so it's pretty resilient to large data. It is fast. I've noticed this myself. The performance is very, very good in SAS. And they have dedicated customer support. They are a commercial company, so they're going to be expensive, and sometimes it's not as easy to just Google the answer. Now, saying that I am not an advanced SAS programmer, do you see any improvements that you could make for my code? Definitely put those in the comments. So the thing you'll notice with SAS is you have proc, run, and then data run statements. These are procs. That's where it's calling something. Data is more when you're doing a loop. So here we are loading into the train variable. And this is the thing that I find the most confusing with SAS. When I'm marking variables like mine as one of the parameters, is that input or is that output? This is, in this case, output. So it is loading the Titanic data set and putting it into train. I'm going to fill in the missing ages with their median. So my output is train. My input is also train. And I'm putting in the median for the age. I am going to split the training and validation sets. Sample size is going to be 0.7. Pretty sure there's a better way that I could combine both of those, but that's what I came up with now. I'm essentially doing two loops. I am building the validate set and the train set just based on if this flag called selected that was put in by survey select was 0 or 1. If you know a better way to do that, give me some code in the comments and I would love to take a look at it. Fit the model and predict. This is fitting a logistic to it. Here I am specifying the gender and the categories, the categoricals, and I'm specifying the other values that I'm using here as well. So survived, this is sort of an equation. We'll see that R does this too. Survived is equal to all these others coming in, and then I have to specify which are my categoricals. Notice I'm not doing the dummy variables myself. SAS is doing that internally. Then I'm going to predict. I'm going to call the logistic, giving it this model. I'm going to score and validate it. Now there is a way you can combine these two together, but I wanted to keep them separate because when I go to deploy these, often I want the training completely separate than the predictions. And then I'm going to turn the predicted probabilities into class values so that we have survived versus not survived, and then finally evaluate and output that. Julia is the next language. Julia is a newer language. It has a very strong following, but I'm not yet seeing it really become a mainstream data programming language, but it does definitely have some interest. Reasons to use Julia: the function and ease of use of R and Python with the speed of Java and C++. I don't necessarily consider Julia to be as easy to use as Python, and we'll get into that in a moment. It has direct calling of low-level C, C++, best of breed open source. Fortran and C libraries are available. Optional typing, now that's interesting. You can type or you cannot type. That can get a little confusing. Built-in extensive multiprocessing and distributed things. Now too, when you talk about a language being easy or hard, there's a little bit of the emperor's new clothes in this. You almost feel dumb saying, yeah, that programming language is complicated. Yeah, I'm pretty much beyond that. I find Python a lot easier to use than some of these languages. And I find Python a lot easier to use than Julia and Scala. So that's just my opinion. I know there's people that love these other languages and probably think Python is a toy scripting language, but that's okay. We all have our opinions. Reasons not to use Julia. It's a bleeding edge language with a growing community and package support. It's a rare programming language. You think it's difficult to find a Python data scientist? Good luck with Julia. Very cutting edge, growing, but relatively small community. Confusing type system because it's optional and it has separate types for NAs. Steeper learning curve than other languages. And some questions of its performance versus other languages. I put this in here too just because I do not deal with Julia on a day-to-day basis. So if I go a few months or a year with giving this presentation, I always look at my Julia code and have to think, what is going on with these various things? Semicolons, they're optional. But if you're running it in the REPL where you're entering commands one at a time, if you don't put a semicolon on something, it's allowed to output. If you see a function with an exclamation point behind it, that's just a convention. And a convention means you don't have to do it that way. It's just usually done that way. The exclamation point means that that function is going to modify the arguments being passed to it. And arguments are passed by sharing, so they're somewhat both reference or by value. Putting a colon in front of some name, that creates a symbol. We'll see that. This is similar to the map and dictionary keys that you pass in other languages. This is an important one. If you put a dot in front of a function or an operator, that gives you its vectorized form. So dot tilde basically gives you a vectorized not, as opposed to a scalar. So single value versus array. Scalar, single value, array, vector. And here we go. So if you first look at this, all these weird operators in Julia can make this kind of confusing. So there's the exclamation point. This just means we're deleting these, and the exclamation point means that this delete is going to modify the values passed to it. So in this case, the data frames. These are essentially symbols, so that it's kind of like putting it in quotes in other languages, but they have a whole separate type for symbols. So these are like your keys in a dictionary. Those are your column names. Here I'm going to do is NA, and notice it has a dot behind it. So this is the vector form of is NA. So it's checking a whole array of things, not just one. So I am taking the data frame, those that are NA, for age, and I am going to set those all to the median of age. And I'm doing some tilde not stuff here where I'm basically only passing in those ages that we have a value for so median doesn't blow up. You can't take the median on something that has missing values. Then the data frame, if we're missing a city, I set it to Southampton. And then I essentially copy those values in. Then I'm going to set up my training test split and shuffle. And now I get my train and validation sets. These colons that you see here alone, this means exactly the same thing as it does in Python, all. So all the columns. Here I create a GLM and I create a formula for it. The formula is in very similar form to what you see in R, and you do specify binomial and linked function for it. So you're not just saying logistic regression, you're saying a GLM and then what family and what the link function is. Then we predict it, we convert it in round so that we can now display the accuracy. MATLAB. MATLAB is very popular in certain domain, particularly finance and quants. What you're doing here is so reasons to use MATLAB. Everything's a matrix. If you're dealing a lot with matrices, it's quite consistent. It has very advanced graphing. If you've used matplotlib in Python, you've used something that was very much based on MATLAB. It can be great for quick prototypes of machine learning applications. Has an extensive toolbox support for very specialized tasks. And Simulink, people are very fond of that. I have really not worked with it, but it's a graphical programming environment for modeling, simulating, and analyzing multi-domain dynamic systems. It's expensive, like most of these commercial packages. Octave is sort of the free version of it, but it does not support everything. MATLAB does have performance issues, so you need to be using built-in libraries whenever possible, and it does have a steeper learning curve than Python. Semicolons. Same thing as Julia. If there's no semicolon, it's going to produce output. So I read a table. I set the age where it is not a number to the not a number mean. That just means ignore not a numbers. I handle my categories. I turn them into a categorical, which is essentially going to result in dummy variables. You see the colon notation here? That means all rows, just like it does in Julia and Python. I'm going to split the x and y. You'll notice some of these languages too, they want x and y split. Others like R and SAS, you don't have to specifically split the x's and the y's. And again, the y's are what you're predicting, the x's are what you're using to predict the y. And you then basically create the matrix and begin to split this apart. So we're taking the training and separating that into the x and y. Going to split the model, use GLM fit. You pass in the x's and the y's separately. It's binomial and the link function is logistic. So this is very much making you specify the type of GLM you have rather than using something called logistic regression, like some of the other languages did. Then I'm going to predict, round, and finally print out the accuracy number. Notice no semicolon. So the ratio printed here would actually be output to you. PySpark. It's not a programming language itself, but it allows you to make use of Spark from Python. Brings the power of Spark into Python. Python code can be executed in parallel over large grids of computers, extensive support for machine learning, data processing, highly scalable through Spark, and the performance issues of Python become less of an issue. It's also compatible with the Spark anyway, is compatible with the JVM ecosystem. Reasons not to use Spark, PySpark. Spark might be overkill for simpler projects and end up actually executing much slower with more hardware. Libraries such as Dask may give you everything you need and maintain compatibility with scikit-learn and pandas. Definitely look at Dask. It's pretty cool. I'll probably be doing a separate video just on Dask. Here is my PySpark example. You have to connect to your Spark session, and I can get these. Here I'm specifying an S3 bucket, but this is a local path. Sometimes I use S3, AWS, sometimes I don't. I'm reading it from here, so I probably should take the S3 off of there just to be non-confusing, but be aware for here it was a local path. I get the passenger count, print out how many passengers I'm dealing with, calculate the median age so that I can fill that in for missing values. I'm going to drop all the values that I do not want. This is more of a Spark data frame drop, so that's why it looks a little different than what we saw before in Python, which was a pandas drop. I'm going to generate the feature vector and do a train test split. Here I'm going to fit a random forest rather than the GLMs I was using before, but it's a decision tree classifier. I'm going to fit it, then do the prediction and transform that and show the actual predicted values. I'm going to display the accuracy and the test error for it. Scala, the last programming language we'll look at. Scala will look similar to PySpark. Spark itself is written in Scala. Scala is the language that Spark was written in, considerably faster than Python, very advanced source board for threading and true concurrency. Some prefer the stronger type safety compared to languages like Python. And the machine learning models you're creating at the low level can be implemented completely in Scala without the need for something like C++. It's a complex and difficult to learn language. It can be difficult to find programmers for it, and it does have the overhead of a JVM language, so that can be good or bad. Here's the Scala example. I'm using an SQL context, so I'm basically loading this from an SQL table. Notice the dollar signs in front. That is just specifying a variable name. That's actually more of a Spark thing than a Scala thing. I get the mean age and fill it in where it's missing. I'm setting up the label indexer so that I can convert categoricals and perform that conversion. I'm building up a basic pipeline here that I'll be able to execute as a graph. I am doing all the conversions that I have to do here. This allows me to do this both on the training and on the prediction scoring side and not have to re-implement a lot. I set up the pipeline and I fit it. And I get the results back and prepare that process. I drop the passenger ID so that I can perform my accuracy calculation. And then I display essentially my accuracy and predicted values. Thank you. Any questions? Put those in the comments. Thank you for watching this video. This is just some information from a conference presentation that I had. If you like this sort of thing, please click the like button and subscribe to my channel. Thank you very much.